Imagine a world without electricity, a world where darkness prevails as soon as the sun sets, and the only source of light is a flickering candle or a dim lantern. No lights to guide you home, no phones to connect you with loved ones, and no computers to work or play on. This was the world before Michael Faraday made his groundbreaking discovery, a world on the brink of a technological revolution. In the 1830s, Faraday discovered a fundamental principle of physics that we know today as Faraday's law of electromagnetic induction. This principle would change the course of history. This law states that a changing magnetic field can create an electric current in a nearby conductor. It was a revelation that opened new doors for scientific exploration. Imagine a magnet moving near a coil of wire. This simple yet profound concept laid the foundation for modern electrical engineering. The moving magnet creates a changing magnetic field, a dynamic force that interacts with the wire. This changing field induces or generates an electric current in the wire. This discovery was revolutionary, paving the way for the development of electric generators and transformers. It showed that electricity and magnetism were not separate forces but rather two sides of the same coin. This unified understanding was a major leap forward in physics. Faraday's discovery opened up a universe of possibilities for harnessing the power of electricity. Today, his work powers our homes, fuels our industries, and connects our world in ways he could have only imagined. Faraday's law is not just a scientific curiosity, it's a fundamental principle that has revolutionized the way we live. It's the bedrock of our modern electrical world, forming the basis for the vast networks of power that light up our cities and power our industries. The most significant application of Faraday's law is in electricity generation, where it plays a crucial role in converting mechanical energy into electrical energy. Almost all the electricity we use daily comes from generators that rely on this principle, making it indispensable to our daily lives. Power plants, whether fueled by coal, gas, nuclear energy, or renewable sources, use massive generators to produce electricity, ensuring a steady supply of power. These generators contain coils of wire rotating within powerful magnetic fields, a design that has remained largely unchanged since its inception. As the coils spin, they cut through the magnetic field lines, inducing an electric current in the wires, a process known as electromagnetic induction. This process of electromagnetic induction is the heart of power generation, driving the engines of our modern world. Without Faraday's law, we would not have the electricity that powers our homes, industries, and cities, fundamentally altering the way we live and work. Faraday's law is not confined to power plants. It's at work all around us, in countless devices we use daily. Whether you're charging your phone, using your microwave, or even just turning on a light, Faraday's law is quietly at play, making these everyday actions possible. From the simplest transformers to the most complex MRI machines, Faraday's law is the invisible force driving their operation. In hospitals, MRI machines use this principle to create detailed images of the human body, aiding in diagnosis and treatment. Take transformers, for example. These devices use Faraday's law to change the voltage of electricity. They are essential in our power grid, ensuring that electricity can travel long distances without losing efficiency. They contain two coils of wire wrapped around a shared iron core. The primary coil receives the incoming voltage, while the secondary coil delivers the transformed voltage. When an alternating current flows through the first coil, it creates a changing magnetic field that induces a current in the second coil. This process is fundamental to the operation of many electrical devices. This simple but elegant application of Faraday's law allows us to step up voltage for efficient, long-distance electricity transmission, and then step it down again for safe use in our homes. Without this, our modern electrical infrastructure would be impossible. Electric motors, generators and wind turbines, induction cooktops, and countless other devices all rely on Faraday's law for their operation. It's a principle that powers our world, from the smallest gadgets to the largest machines, making modern life as we know it possible. Section 4, Faraday's Law, the cornerstone of electrical engineering. For electrical engineers, Faraday's law is not just a law, it's a fundamental truth that underpins their entire discipline. It's the foundation upon which they design, analyze, and innovate electrical and electronic systems. Understanding Faraday's law is crucial for designing everything from power grids to smartphones. Engineers use this law to calculate the induced voltage in circuits, predict the behavior of electromagnetic devices, and develop new technologies that harness the power of electromagnetism. It's a tool they use every day to solve real-world problems and create the technologies of the future. Section 5. The inescapable nature of Faraday's law. Faraday's law is not something we can choose to ignore or escape. It's woven into the very fabric of our universe. It's a fundamental law of physics that governs the interaction between electricity and magnetism, a dance of forces that shapes our world in countless ways. From the vast magnetic field of the Earth that protects us from harmful solar radiation, to the electrical impulses that travel through our nervous system, Faraday's law is always at play. Section 6. A universe intertwined with electromagnetism. Faraday's law is a testament to the interconnectedness of our universe. It reveals that electricity and magnetism are not isolated forces but rather two expressions of a single fundamental force, electromagnetism. This force is responsible for a vast array of phenomena, from the behavior of atoms to the structure of galaxies. As we delve deeper into the mysteries of the universe, Faraday's law continues to be an essential guide, illuminating the path toward a deeper understanding of the cosmos and our place within it.